Okay, so this is a continuation from the previous video. We built a common emitter stage and we want to connect a speaker to it directly and see what happens when you connect a speaker directly to the common emitter stage. So what I'm going to do is I will run this circuit and look at the gain is the output. We saw that bringing the emitter resistor improved stability, so our gain error was fixed, but then the gain is reduced. Sorry, the bias error was fixed, but the gain was reduced. By putting a bypass here means that the AC signal will bypass the emitter resistor, which will improve our gain. So our gain is improved, and we are going to decouple our small signal output or AC output from the operating point DC fixed output. So I'll just separate with a capacitor, and this is representing an open circuit. So now we see the output alone, compare it to the input, you see the significant gain. If I take out the bypass capacitor, I'll see that the output reduces significantly. So I'm bringing back my bypass capacitor, so then I have the advantages of the stability improvement as a result of the emitter, the generator, but I also have the full gain, almost full gain, because I've bypassed that with respect to the AC signals. So what I'm going to do now is I'm going to connect my speaker, which is 8 ohms, and see what happens. So our 8 ohm speaker, and I run this, and the red is the input and the blue is the output, and we see that it's not working because the gain has now become minus GM RC in parallel with 8, and RC in parallel with 8 is almost 8, so GM times 8 means our gain is less than unity. So this is when the trick of the emitter follower comes in. I'm going to pick my, and rather than connecting this directly, I am going to connect this to the emitter. Okay, so the question is, should I worry about bias? Let's see. And I will tie this to the VCC. And I'm going to connect my RE here. Let me just use 100 ohms as I used before. And I move it down a little. Okay, let's see the room. Okay, so I'll connect my speaker here, my 8 ohm speaker, to the ground, and I ground this side too. So 8 ohm speaker. Okay, so let's run and see what signal the speaker is going to see. Saying that overlapping component found. Okay. Alright, so the issue is we can see that there's no current flowing through our IC2. if you look down here, you see it's in nano ampere. So that's troubleshooting. That's the first thing we look at, and that tells us that the voltage at this node is not enough to so even though we have this voltage, but the operating point voltage is 419. So let me just raise it up by 250 volts and see if this works. I can easily use a biasing technique to obtain that. So let me just put this 250 0.25. Okay, now the operating point voltage. Okay, so I did the wrong, I think the terminals were interchanged. Did it. Okay, so we are going to run this and see. Check our operating point voltage, and still not working. So what could possibly be the cause? Okay, so we are going to put a resistor here. We did not do that, so let's put a resistor 1k there. Run that. He didn't do this. Okay, so now our transistor is still in soft saturation. Okay, so what happens now is that our transistor, so in troubleshooting, we realize that the voltage here is 11.1111. That's because the transistor is not in, because the voltage at the base emitter is way less than that of the so we will just try our simple biasing technique here. So it's about biasing. It's not well biased, so I'm going to delete this. One thing we know is the simple biasing technique would always put our device in forward active mode. So I'm just going to repeat without doing any weird calculations. Don't worry, there are a lot of try and errors in electronics. That's why simulations are always there. But whenever there's an error, you try to understand the error, and through that you learn. So we run that and we check the operating voltage. At least we have 0.9 volts. If the emitter voltage is around 200, then it means we are having the right VB. So the emitter voltage is around 68. So that means I have the VBE to be 800 and something. Okay, so let's see what happens to the output. So there are clips. and clearly we see that the okay, so let's go deeper to analyze what is wrong with our circuits and try and fix it. So our biasing technique should be okay, and the current through this is 9 milli, which okay, to RE over RE trans. Let's just keep this up and see if possibly is part of the reasons we didn't do any calculation in choosing that. Okay, we are still getting some distortions, so it's about optimizing the values of okay, so our now what is happening here is our input signal and our output signal, so we can also decouple the sorry, so let me try and decouple that the output. Okay, so I will put 20 micro here. What is that? Okay, not so much gain, then I'm going to stick to 100, and I'll change my biasing technique to something similar to what was done before, what is okay. I'll just repeat the values there: 3350, 5460. Okay, connect it up. Okay, so I'm going to test the operating point. So first I have 1.4 and I have 6.9, so it means it's in forward active region. Then what about the emitter? 1.4 minus 580, almost 800. That should be fine. Let's see. So we have the 5 millivolts giving me gain of times 5, but there are a lot of distortions, and what could be the reason? 500. Okay, so almost there in building our circuit. REGM of our biasing. Well calculated. So okay, I think the calculation that was done for the biasing was for the problem is the current, the IC current is probably too high. Let's see. Okay, I'm getting a gain of 14. Why the distortions? Okay, so I now suspect the value of my capacitance. So let me look at that and see if it improves. Then that will be the issue. Okay, so let me go higher. Okay, so at the right frequency to 100 micro. Okay, our eclipse. So it's the issue is with the biasing and the capacitance values that I have. So a slight increase in the feedback correction. Um, 160, but they are clipping headroom. I don't have enough headroom. Okay, so I think okay, so I think the signal coming in, let's check out the signal coming in. Okay, so the signal coming in is too huge, so it's driving the device crazy. So I think this guy should do the trick. And that is it, we solved it. So after a bit of troubleshooting, what I noticed that guy was doing was the one causing the issue. In being greedy, connecting this bypass capacitor meant I was getting huge gains here, and that means that the signal coming in would move the VBE way above 800 and way below that when it adds up. So in maintaining the signal here by taking out the bypass capacitor, then at least I still have some reasonable gain with stability in both AC and DC. But when it comes here, I have 1.3 take away 500, roughly around 800. So the signal coming in will not drive this to VB of 900, which will make the transistor misbehave. So now the gain is not much. I'm sure we can look at how to further improve this. At least for now we've got some gain without attenuation. Of course, we know that okay, so let me split the two to first the signal coming in. Okay, so this has already added the bias point here. So unless I manually subtract this voltage 1.308, I wouldn't really see. So 1.308 if I really see the signal that is coming in. And of course, there will be little attenuation. So if I want some more gain, now from theory, if the value of RE is big enough, make this 500, then I'm expecting some gain, but I think I overdid it, so I'll slightly reduce it to 300 and see. I think I reading current. Yeah, okay, didn't really change by much, but at least what we've done is we can look at the input and connecting the emitter follower. We have seen that we got some gain, not much, but at least it's better than connecting the speaker directly to the emitter stage. In that case, the signal was attenuated. So this still needs some improving, and I'm sure we would try and improve upon it in the next video. So until then, goodbye.